Hello children, we now begin with question number 11 of the problem set. Question number 11, in triangle ABC, angle BAC is 90 degrees, segment BL and CM are the medians of triangle ABC. Prove that 4BL square plus CM square is 5BC square. Okay, so to do this question number 11. Yeah. Now you are given triangle BAC, which is right angled at A. You are given CM and BL are the medians. So you have CL equal to AL, BM equal to AM. Okay. Now what we'll do is consider triangle BAL first. Now using Pythagoras theorem, BL square is BA square plus AL square, equation number 1. In triangle CAM, CM square is CA square plus AM square, equation number 2. Add both equations 1 and 2, you get BL square plus CM square equal to BA square plus AL square plus CA square plus AM square, equation number 3. Now in place of AM, I can write it as half BA, and in place of AL, I can write it as half C. Now substituting for AM and AL in equation 3, I get BL square plus CM square equal to BA square plus half of CA the whole square plus CA square plus, in place of AM, I'll write half BA the whole square. Now when I square it, I get 1/4 CA square and 1/4 BA square in its place. Now, since I do not want the fractions, I'm going to multiply throughout by 4. So I'll get 4BL square plus CM square is equal to 4BA square plus CA square plus 4CA square plus BA square. Now, there are 4BA square plus BA square, that makes it 5BA square. CA square plus 4CA square is 5CA square. Take 5 common out. What is BA square plus CA square? When you look at the figure, BA square plus CA square is BC square. So in place of BA square and CA square, I replace BC square. So I get 4BL square plus CM square is 5BC square. And that is what has to be proved. Okay. Now we go to question number 12. Question number 12. Sum of the squares of adjacent sides of a parallelogram is 130 square centimeter. Length of one of its diagonals is 14 centimeter. Find the length of the other diagonal. Now, this is an important question usually asked. You have parallelogram ABCD. Okay, you are given AB square plus BC square is 130 centimeter square. You are given one of the diagonals is 14 centimeter. So AC is 14 centimeter. We know the diagonals of a parallelogram bisect each other. So half of it AO will be 7. You have to find the length of the other diagonal. Now what we'll do is take triangle ABC. Now since BO is the median, I can use Apollonius theorem. So AB square plus BC square equal to 2BO square plus 2AO square. Now you are already given AB square plus BC square is 130. So substitute it. 2BO square plus 2 into, in place of AO, I can substitute it as 7. So 7 square 49. 2 into 49, 98. Bring it to the left hand side. You get 32. You get the value of BO as 4 centimeter. And BD will be twice 4. Therefore, the length of the other diagonal is 8 centimeter. Okay. So that's how question number 12 has to be done. We go to question number 13. Question number 13. In triangle ABC, segment AD is perpendicular to BC. Prove, you are also given DB is 3 times CD. DB is 3 times CD. Prove that 2AB square equal to 2AC square plus BC square. Okay. Now to do this, question number 13, you have triangle ABC. You are given DB equal to 3 times CD. You have to prove this. Now in triangle ADB, we know angle ADB is 90 degrees. Therefore AB square equal to AD square plus BD square by Pythagoras theorem. Now AB square equal to AD square plus, you are given BD is 3CD. So substitute that in BD's place. So you get 9CD square. Now when I multiply throughout by 2, I get 2AB square is 2AD square plus 18CD square. Mark it as equation number 1. Now take triangle ADC. Pythagoras theorem, AC square equal to AD square plus CD square. We are just multiplying that equation by 2. So you get 2AC square equal to 2AD square plus 2CD square. That's equation 2. We know that BC is equal to BD plus DC. In place of BD, substitute 3CD. So BC we get equal to 4CD. Square both the sides. BC square equal to 16CD square. Call it equation 3. Add 2 and 3, you get 2AC square plus BC square equal to 2AD square plus 2CD square plus 16CD square. So you get 18CD square. So the final equation number 4 is 2AC square plus BC square equal to 2AD square plus 18CD square. Now there is a reason why we have done all this. If I compare equations 1 and 4 and look at the right hand sides, you find both of them are the same, that is 2AD square plus 18CD square. And both of them are equal to the left hand side, which I can equate, and so I'll get 2AB square equal to 2AC square plus BC square. And that is what has to be proved. Okay, so that's question number 13. Now we go to question number 14. In an isosceles triangle, length of the congruent sides is 13 centimeter and its base is 10 centimeter. Find the distance between the vertex opposite the base and the centroid. Okay. Now, what is a centroid? A centroid is a point where all the medians of a triangle will meet. There is a property which we have learned about the centroid, that the centroid divides the medians in the ratio 2:3. So I have a triangle ABC. AB and AC are 13 centimeters each. BC is 10 centimeters. We have drawn AM, okay, which is the median. It meets the centroid at the point G. So AG is to GM is 2:3. Now for construction, draw segment AM which is perpendicular to BC such that B dash M dash C. Okay, so AM is the perpendicular. In triangle AMB and triangle AMC, you have angle AMB equal to angle AMC is 90 degrees. That's given. Now AB is congruent to AC. It's given as 13 centimeter. AM congruent to AM, common side. Therefore, these two triangles AMB and AMC are congruent by hypotenuse side theorem. Hypotenuse side theorem. Okay. Therefore, since the two triangles are congruent, it follows that segment BM is congruent to segment CM by CSCT. And therefore, it is half of 10, which is 5 centimeter. Children, I hope it is clear. What did we do for construction? We drew AM, which is perpendicular to BC, such that B dash M dash C. You consider those two triangles. They are congruent by hypotenuse side test, and therefore by CSCT, BM equal to MC, and both of which is equal to 5 centimeters. Now in triangle AMB, AB is 13. We have BM as 5. So we can easily find out AM using Pythagoras theorem. You get AM as 12 centimeters. Okay. Now AM is the median. Point G lies on it. Therefore, by centroid property of a triangle, we know AG is equal to 2/3 of AM. So 2/3 of 12, answer comes 8. Therefore, the distance between the vertex opposite the base and the centroid is 8 centimeters. So that's how we get the answer. Okay, that's question number 14. Next, we go to question number 15. Question number 15 says, you have a trapezium ABCD. Segment AB is parallel to DC. Segment BD is perpendicular to AD. segment AC perpendicular to BC. You have to find out, AB is also given 25, you have to find area of the quadrilateral ABCD. Area of the quadrilateral ABCD, which is a trapezium. So this is how we have to do it. Question number 15. So we have drawn the trapezium ABCD. AD is 15, BC is also 15, AB is 25. We take triangle ADB. We know angle ADB is 90 degrees. Use Pythagoras theorem. AB square equal to AD square plus DB square. So 25 square is 15 square plus BD square. From there I can find out BD, which will be, answer I get DB as 20. Okay, I'll get 20. BD is 20. Same method I use for AC, and I'll get AC also as 20. Now, what is area of triangle ADB? Since it's a right angle triangle, I can say it's half base into height. So half into 15 into 20, I get 150 square units. Okay. Now, for construction, we'll draw DM perpendicular to AB such that A dash M dash B, and CN also perpendicular to AB such that A dash N dash B. Now I know area of triangle ADB is 150 square units. We have already found out. So what we'll do is, we are going to find area of triangle ADB in a different way also. So 150, which is the area of triangle ADB, that is equal to half into the base AB into the height DM. So if I consider DM to be the height of the triangle ABD, I can write it as half into AB into DM. So AB is 25, substitute. Area is 150. I can easily find what is the height DM. That will be equal to 12. Okay. So that's 12. Similarly, I get CN also as 12 in the same method. Okay. Now once I have found this out, take triangle DMA. Take triangle DMA. Okay. I have got AD as 15 and DM as 12. I can easily find out what is AM using Pythagoras theorem. So I get AM as 9. Okay, AM is 9. Similarly, I know BN is also 9. So AM is 9. Same method I can use for the other triangle, that is CNB, and I can get BN as 9. Now AM is 9, BN is 9, the whole value is 25. So I can find out how much is MN. So 9 plus 9, 18, 25 minus 18, I'll get the value MN as 7. Okay. Now in quadrilateral DCNM, consider this quadrilateral DCNM, I have got MN as 7. You are given DC is parallel to AB. It's a trapezium, right? So DC is parallel to AB. You have DM parallel to CM. Okay. See, you have DC parallel to AB. You have DM and CN are the two perpendiculars drawn. Now when you have two perpendiculars drawn and you have DC is also parallel to AB, we know that the perpendiculars, if I consider converse of interior angle property, interior angles are 90 degrees. So I get DM is parallel to CN. So actually I get a parallelogram. DCNM becomes a parallelogram. Reason, DC is parallel to AB, we already know. Therefore DC is parallel to MN. DM and CN are perpendicular to AB. Therefore the interior angles being supplementary, even DM is parallel to CN. So when opposite sides are parallel, you have got a parallelogram. DCNM is a parallelogram. Now, if it's a parallelogram, opposite sides are congruent also. Opposite sides are parallel and congruent. So if MN I have got it as 7, I know DC is also 7. That's how I get DC as 7. Okay. This is what is explained over here. In quadrilateral DCNM, DC is parallel to MN. DM is parallel to CN because both of these are perpendiculars. Quadrilateral is a parallelogram. Opposite sides are parallel and congruent. Therefore, Mn equal to DC equal to 7. Now, I have a trapezium wherein AB is 25, DC is 7. and the height is DM as well as CN together. I have found out the value as 12, isn't it? Therefore, I can easily find the area of the trapezium half into sum of the parallel sides into the height. So I can find half into 25 plus 7 into 12, answer 192 square units. Okay, children, I hope it's clear. Go through this question once again carefully and try to understand how we have found out. First thing we did was we found out the value of DB because I know AB and AD, it's a right angle triangle. So I found out DB as well as AC. Okay. Now I found out area of that triangle ADB, half base into height. All right. So I got the area. Now we drew perpendiculars, DM and CN. Now I know the area, I know the base, so I could find out the height. DM I found out. Okay. Now once DM and CN I found out, I know the height of the trapezium. Okay. Now once I knew the height from the base 25, I could find out, I took triangle DMA. I know DA is 15, DM the height I know, so I could find out AM. Same way I found out BN. So once I know AM and BN, subtracted from 25, I got MN. Okay. Once I found out MN, I proved DM and C to be a parallelogram. Therefore, opposite sides are parallel as well as congruent. So I found out DC is equal to MN, which is 7. So now in this trapezium, I have all the values. Parallel sides I know, height also I know, and therefore substituted in the formula half into sum of parallel sides into height. And so I've got the area of the trapezium as 192 square units. So this is how it's to be done. It's a little lengthy sum, but not difficult. Go through the steps once again and understand it clearly. Okay. We go to the next question, number 16. Now in this figure, triangle PQR is an equilateral triangle. All angles are 60 degrees, all sides are congruent. Point S is on the segment QR such that QS is 1/3 of QR. You have to prove 9PS square equal to 7PQ square. So question number 16, proof. Draw PT perpendicular to QR such that Q dash T dash R. Now, since triangle PQR is equilateral, PQ equal to QR equal to PR, and all angles are 60. In triangle PQT, angle Q is 60, angle T is 90 degrees. Therefore, angle QPT has to be 30 degrees. Side opposite to 30 is half of the hypotenuse. Therefore, QT equal to half of PQ. And PT is side opposite to 60, which is √3/2 times PQ. Now, take triangle PST. ST is equal to QT minus QS because Q dash S dash T. What is QT? It is half of QR. Okay, it's half of QR. Now it's an equilateral triangle. We have drawn the perpendicular bisector. Therefore, it is the perpendicular bisector median is all the same for an equilateral triangle. Therefore, QT can also be written as half of QR, and instead of QR I've written it as QP because it's an equilateral triangle, all sides are equal. So half of QP minus QS is given 1/3 of QR, and QR I will again write it as QP. So I'll get ST as half QP minus 1/3 QP. Take PQ outside and half minus 1/3, 1/3, find the LCM, I get 1/6 PQ. ST is 1/6 PQ. Now in triangle PST, PT is equal to √3/2 times PQ. Okay, we have got it from this side opposite to 60 degrees is √3/2 PQ. I have got ST is equal to 1/6 PQ. So in this triangle PST, I have got PT as well as ST. So I can easily find out PS square using Pythagoras theorem by substituting these values. So I get √3/2 PQ the whole square plus 1/6 PQ the whole square. You have 3/4 PQ square plus 1/36 PQ square. Multiply throughout by 36. You get 36 PS square is 4 goes 9 times in 36. 9 into 3, 27 PQ square plus PQ square. So you get 36 PS square equal to 28 PQ square. You divide throughout by 4. So you get 9 PS square equal to 7 PQ square. So this is how you get that equation which they have asked. Okay. Now, question numbers 17 and 18 are direct applications of Apollonius principle. If you draw the figure, you will find you have to draw, for example, question number 7, draw triangle PQR. PQ is 40, PR is 42, PM is the median, which is 29. You have to find out QR. Okay, so they are direct applications of Pythagoras theorem. You will only find that the numbers that they have given are a little bigger numbers, so finding the squares and the square roots could be a little difficult, but not that you won't be able to do it. So try both of them, 17 and 18, and with that we finish problem set 2. So the lesson Pythagoras theorem is done. We finished with the problem set, children. Try out all the questions. I hope you're solving all the sums as I'm doing it here. So complete all this and see that your books are complete and you have understood all the sums that you're doing. Okay, thank you.